Hi guys. So we are going to talk about this this week. Happy Black History Month, and we'll be pulling in some cool things from the NASA history and the different ways that African American men and women contributed to math and science field. And today, though, we're going to focus on the polynomial key features of the graph still, and one last bit of that, and then operations. We're going to start operations. When I say operations, I don't mean like, cut someone open and look at their arm. I mean, adding in math land, that means adding, subtracting, multiplying, dividing, that sort of thing. And so we're mostly going to be focusing on adding, subtracting, and then multiplying this week. This should be review, but I know sometimes it doesn't feel like review, but hopefully it will. And then next week we'll start dividing. And even when I say dividing polynomials, that'll sound familiar, but then it'll get a little algebra 2 level, right? Algebra 1, we certainly did some dividing of polynomials, but we're going to kick it up to algebra 2 level there. So when it comes to the last piece of features of a polynomial graph, this is just kind of pulling it all together. And when we look at this graph here, let's just kind of get mountains and valleys, if you will. And so when this says the degree of f of x, just by looking at the graph, we don't have the function. If we had the function, we just look at the highest exponent. We don't have the equation of the function. So what we need is we just look at the graph. By looking at the graph, what you're going to look for to decide if it's an odd or even degree, if the ends go in opposite directions, and when I say opposite directions, what I mean is, on the right side, it goes up, but on the left side, it goes down, or vice versa. On the left, it goes up, on the right, it goes down. If they go in different directions, then that would be what's called an odd degree graph, a graph of an odd degree function. If they go in the same direction on the graph, doesn't matter what they do in the middle, right? They both go up or they both go down, then that is considered an even degree function. So let's look at this graph right here. Are they going in the same or the opposites? Opposites. So since they're going in opposite directions, then we know that it is an odd degree function. Okay? Since they're going in opposite directions, we know it's odd. Odd is opposite. Opposite is odd. Odd is opposite. Opposite is odd. Now, when it comes to understanding the leading coefficient, the leading coefficient could be any number, and it can be positive or negative. They're not asking what the number is. They're only asking if it's positive or negative in here. When you click on that button, the options are positive or negative. And the way that you know that is looking right here. So leading coefficient, look at the right side of the graph. And if the right side of the graph is going up, then your leading coefficient is positive. If the right side of the graph is going down, then your leading coefficient is negative. Okay, I'm not asking anything about the left side of the graph or in the middle or anything, literally just the right side as x approaches infinity. So if we look at this graph, we go from the left to the right, it goes up, down, and then it goes up for the rest of the time. Okay, since it goes up for the rest of that time, that tells us that the leading coefficient is positive. Now, as far as the distinct real zeros, there are several ways to ask that same question, right? You can ask me where are the x-intercepts, what are the roots, and where does it cross the x-axis? Those are three different ways to ask the exact same thing, almost the exact same thing. Roots could actually be non-real, and we'll learn about those later. But x-intercepts and where across the x-axis are, in fact, other ways to say what are the distinct real zeros. And in this case, what we're going to look for, okay, so where are the places that this graph crosses the x-axis? So I'm going to zoom in a little bit. And I just want to know how many for now. Here's 1, 2, 3, 4, 5, 6. I literally just want to know how many times does it cross the x-axis. Turns out it crosses the x-axis 6 times. 1, 2, 3, 4, 5, 6, but they are not. So the distinct real zeros, how many times does it cross the x-axis? Last thing, relative extreme values. Relative maximum means what would be the top of a little hill, like this. That would be that guy right there, right? And the relative minimum would be this guy down here, the bottom of a little dip. So if I look at here and they're asking how many, how many times does this thing have a top of a hill or the bottom of a valley or a little dip? Well, there's the top, there's a top, there's a bottom, there's a bottom, there's a top, and a bottom. So 1, 2, 3, 4, 5, 6. We would say right here, there are 6 relative extreme values, okay? You can think of this like a roller coaster. Where would the top of the hill be and the bottom of a dip? Top of a hill, bottom of a dip. Top of a hill, bottom of a dip. Okay, we don't count the ends because it looks like they're going on forever. Okay, now when it comes to adding and subtracting polynomials, you're going to combine like terms, and you have to have the exact same letter and the exact same exponent on the letter to be able to add and subtract them. And then once you've got them the same, you don't change the exponent when you're adding and subtracting. Because remember, exponent is about multiplying. You only change the coefficient if it's applicable. So first thing, example, we're going to line these up so they're like terms. So it says 10x squared minus 10x plus minus 6, and then I've got x plus 6. Okay, well, what other one is a like term with x? It has the exact same letter and exponent on the letter. Let's see, so we got 10x squared minus 10x minus 6. Okay, so we got those, and now we got to do x plus 6. X, I'm going to put underneath that x, and a plus 6, I'm going to put underneath that number. If there was an x squared over here, I would put it underneath this x squared. Then we figure out, are they asking me to add or subtract the things? Well, they're just saying to add them. So it's 10x squared. Now, to combine these like terms, negative 10 plus 1, right? This is a hidden ninja 1. So negative 10 plus 1 would be negative 9. And negative 6 plus 6 is 0. So that's it. This is my answer. This is what I would type in. This is exactly what I would type into the assignment on Delta Math. All right, let's try another one. This time it's telling me to subtract, but I'm going to line up my like terms first. So I've got my 6x squared plus 7x plus 2. Now I'm going to put my x squared underneath the x squared. My negative 10, there's no letter, so I'm going to put that under the one that's no letter. Remember, no letters are actually called constant if they don't have a letter. Constant. They're both constants. And I'm going to put like a equal sign underneath them. Now, this time I have to be a little bit careful because this says minus. So when I go to subtract these, here's the fastest way to handle that. Because it says subtract, fastest way and simplest for most students to handle that is change all the signs, positive and negative, on the second expression. Okay, so this negative 9x squared is not going to be a positive 9x squared. This negative 10 is now going to be a positive 10. Because to change the sign is the same, change the signing and adding is the same idea as subtracting. So now that I have changed the signs because it was subtraction, and I've lined everything up, I just combine my like terms. So I can add them now, right? Since I changed the signs, now I can just add straight down. So 6 plus 9 is 15x squared. 7x plus nothing underneath it is still 7x. And 2 plus 10 is 12. That would be my answer. Okay, so adding and subtracting. If you're adding, line them up, add them together. If you're subtracting, line them up, change the signs, add them together. Change the signs to make your life easier. Okay, now these get a little bit trickier. This is like the algebra 2 version of this, right? Where it says, if A is this and B is this, find an expression that it equals 2A minus 3B. All right, so I'm going to kind of color code this. So let me make A this kind of bluish looking color. So to figure out what 2A is, that means multiply everything that was in A by 2. So 2R squared plus 6R plus 1. I'm just going to deal with that first, okay? So we're going to distribute. We're going to multiply this 2 by everything in here. So now we have 4R squared and then plus 2. Okay. So are there any terms that I need to combine? Nope, they have different letters and exponents. We're okay. So there's 2A. Now I've got to do negative 3B. Now here's two options. You could just find 3B and then subtract, or we could go ahead and do negative 3B, and that'll help us keep our signs in check, right? Remember, we can change the sign and add them. So that's what I'm going to do this time. Negative 3B. So it's going to be negative 3 times all the stuff that it says B is. Multiply negative 6R. Negative times a negative is positive 18. Okay, so now I've got my 2A and my negative 3B. Now I can combine my like terms together. And then I'm going to combine the two together. And since I already changed the sign here, I already did my negative in there, I don't have to worry about putting another negative in. I can just add this. 12R plus a negative 6 is 6R. 2 plus 18 is 20. And there is my answer. Okay. Now when it comes to multiplying, when we were doing multiplying a second ago, it was just a number times all the stuff in a polynomial. This time we're going to be a polynomial times a polynomial. And the trick is keeping everything straight. So there are two ways to do this. There's tons of ways to do this. I'm going to show you two ways. One is with a box, keeping everything straight and organized, and one is without. When you're doing this on your own, you get to pick. So if you're not going to use a box, the idea here is first you're going to distribute this 2x times everything in here, all three of these terms. So 2x times 3x squared, 2 times 3 is 6. X times x squared, x cubed. Then we do 2x times the 5x. 2 times 5 is 10. They're both positive. And x times x is x squared. Notice that these exponents are changing now that we're multiplying stuff. And 2x times negative 2, well, that's going to be negative 4x. Now take a second, make sure you know where all that came from and that you're okay with that part before you go to the next part of the video. And let's do the next part. Now we have to distribute this negative 1 as well into each of these. So I'm going to multiply everything in this trinomial by negative 1. So negative 3x squared negative 5x. Negative times negative is a positive 2. Now, if I was efficient, I would not have lined those up over on the right side. I would have lined them up underneath the blue I'd already written, my like terms. So I'm going to do that now. I'm going to go, okay, so that negative 3x squared that's green, that's got to line up with an x squared in blue. Negative 5x, I'm going to line that up with my negative 4, with the other x. And that is negative 4x. And then I have this positive 2 hanging out on the end. Now I can, since I got them all lined up, this will be easy to combine my like terms. So I'm just going to line them up and add them up. Cha-cha-cha. So 6x cubed plus nothing is 6x cubed. 10x squared minus 3 of those x squareds is 7x squareds. If I borrowed $4 and I borrowed another $5, I have now borrowed $9 plus 2. All right. There's that beauty. Now, another way to organize the same idea, right? We've got 3 things, a trinomial multiplied by a binomial. Another way to organize that would be to put them in a box. So I just made it like a 3 by 2. You could have done a 2 by 3. It would work. But what you're going to do is you're going to take each of these terms and put them on the outside here. 6x squared minus 5x plus 1. And then we're going to take each of these terms and put them across the top, negative x and negative 3. Then you're going to multiply each of those together, okay? And let me use another color. So I go in to do this. This box is first row, first column. So I'm going to do negative 6x squared times negative x. Well, negative 1 times 6 is negative 6. X squared times x is x cubed. What's above it and what's to the left of it, and multiply. So negative 3 times 6 is negative 18. And then we still have this x squared. Negative x times negative 5x is positive 5, then x squared. Negative 3, negative 5x, positive 15x. Negative x, positive 1, negative 3 times 1. And then we're going to combine any like terms that we can, okay? And the cool thing about the box is you'll notice what we did was we took 6x squared and multiplied it by both of these. 6x squared times both of these. We took negative 5x and we multiplied it by both of these, right? All we're doing is distributing. It's just a nice little neat way to keep it all organized. And then if there are any like terms, those like terms will be in diagonals. Notice there's an x squared and an x squared here, and a plain old x and a plain old x. So those are going to be the only like terms I have to do. So when it comes to writing out my final answer here, there's no other like term for that x cubed. So negative 6x cubed. 5x squared plus negative 18x squared. That is negative 13x squared. Then negative x plus 15 is positive 14x. And then I still have that positive 1. So it's not that we don't use those. They just didn't have anything they had to combine together. And then this little glory is the answer. So it is up to you whether or not you use a box when you're doing this on your paper. And totally up to you. No pressure. And here's one more example where this time there's not 2 polynomials being multiplied. There are 1, 2, 3, 4. So you're going to have to do this in a couple steps, but it's the same idea. Pick 2 of them and start there. I'm going to pick the first 2 because I'm so fancy, right? Box or no box is totally up to you. So I'm just going to do 3x times 3x. 3x times 1. Negative 2x plus 3x, or times 3x. So that'd be negative 6x. And I'm already lining it up underneath the like term to make my life easier. And then -2 plus 1. Combine my like terms. This is like step 1. I'm going to do the same idea. 3x times x, 3x squared. 3x times -1. 2 times x. You know what? I'm going to put it down here to line up my like terms. And then 2 times -1. 3x squared minus x minus 1. Okay, so I took those 4 binomials and I turned them into 2 trinomials, right? I multiplied the first 2 and got this blue stuff over here. I multiplied the second 2 and got this green stuff over here. I'm not finished. I did not multiply it all out yet. So now I have to multiply this blue trinomial times the green trinomial. This time I am going to use a box, and here's why. This is going to be a lot of different things for me to keep track of. So it will make my life easier if I go ahead and use a box. This is a trinomial, and this is a trinomial, 3 terms each. So I'm going to need a 3 by 3 box. Okay, don't be jealous of my amazingly straight lines. I know you're jealous. It's okay. Now I'm going to grab the blue ones, and you can either put the blue across the top or across the side. It doesn't really matter. -2. And then I'm going to grab the green. I'm going to put them across the other side. And now we multiply, 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 multiply. Lots of things, lots of things, lots of things. Ready? So for this first box, I go these 2, right? So 9 times 3. X squared times x squared. -3x times 3x squared. -9x cubed. -2 times 3x squared. -6x squared. Negative blah, blah, blah. 9x squared times -x. -9x cubed. Woo! This little problem. Shoo-wee! This one takes some work. So fun. Okay, sorry. I just got excited. All right, so now any like terms that we can possibly have are going to be in little diagonals. So these little guys, see how all the squares are nice and lined up? All the plain old x terms are nice and lined up. 27 x to the 4th. Now I've got to add together. When I say combine like terms, remember we don't change the exponents when we're adding and subtracting, and we just change the coefficients. So -9 plus -9x cubed. I borrowed $9. I borrowed another $9. I have borrowed $18. And now I've got to do this row. So -9x squared plus 3 be -6x squared, right? -9 plus 3 is -6. And then we're going to do another -6. So that is -12x squared. Then 3 plus 2 is 5x. And then 2. Holy moly. That one was so fun. We could do another example if you wanted to, but the idea is, you could use a box to do the same idea. I'm not going to do another one like that in this video. This video is already plenty long enough.